In this video, we are going to learn about something called the trace of a matrix. So the trace of a matrix is an operation that can be done on any square matrix, and you can calculate the trace of this square matrix, and what you get is a single number, which is called the trace of this matrix. Okay? And this single number is very simple to calculate. Let me write it down. Trace of a square matrix A is equal to the sum of the elements on the main diagonal. Main diagonal. So what is the main diagonal? The main diagonal of a matrix is, if you write the matrix elements, maybe a 4x4 matrix, yeah, for example. So the main diagonal is the diagonal that goes exactly here through the center. That's the main diagonal of the matrix. A square matrix means that it has the same number of rows as it has columns. So it's an n times n matrix. Yes? So you just add those n elements of the diagonal, and that gives you a number, which is the trace of the matrix. The trace has a certain properties, so the trace is linear, which means that the trace of a linear combination of matrices is equal to the linear combination of their traces. Another property is that the trace of a product is independent of the order which means that the trace of A times B is equal to the trace of B times A, even if A times B is not the same matrix as B times A, but they have the same trace. And finally, the trace of the identity matrix is equal to its dimension. This is trivial because the identity matrix is a matrix that has ones along the main diagonal. So if we have the identity matrix on a n times n matrix and we calculate the trace of that, that is equal to n. So two simple examples. Here I give you a matrix A which equals 2, 1, 0, 1, and I ask you to calculate the trace. So the trace of A equals 2 plus 1, the elements on the main diagonal, which equals 3. Now consider matrix B, 0, 2, 1, 0. The trace of B is equal to the sum of the elements on the main diagonal. 0 plus 0 equals 0. Now the trace of A times B, first we need to calculate A times B. So A times B equals, let me do the calculation quickly, 1, 4, 1, 0. Is 1, 4, 1, 0. So the trace of AB equals the trace of 1, 4, 1, 0, and is equal to 1 plus 0, which is equal to 1. While the matrix B times A is equal to, let's write it down quickly. So this is B, now I write A. So now the product of B times A is 0 times 2 plus 2 times 0, 0 times 1 plus 2 times 1, 1 times 2 plus 0 times 0, 1 times 1 plus 0 times 1. So trace of B times A is equal to the trace of this matrix here, 0, 2, 2, 1, which is equal to the sum of the elements of the diagonal. 0 plus 1, which equals 1. So this confirms that even though A times B is a different matrix than B times A, their traces are the same. And this is a property of the traces. Okay? So next, I'm going to explain to you what the determinant is. But before that explanation, I'm actually going to recommend you, and I'm going to link it in Kits, a YouTube video by a very good mathematician YouTuber called 3 Blue 1 Brown, where he explains the determinant perfect. I really recommend you to watch that determinant video before the formal explanations that I will be giving. So, see you soon.